Okay, here we go. This is 2.4, day 1, and probably day 2. We're going to talk about the complex number system. Okay, so here's where we're going, right there. Complex numbers, just so you remember what it is, it's all about imaginary numbers. So, to get started, you are asked to remember this. The square root of a negative number does not exist. We can't find the square of a negative number. So in mathematics, they decided there's got to be an answer. So they came up with this imaginary answer, I. So this is a number that satisfies this condition. All right? So what we're trying to say is, what number times itself is -1? That number is now called I, the imaginary number. So what the square root really does ask you is this. What is the square root of -1? I. So I'm telling you, if you take I times I, you get -1. Okay, so that would mean, go over here, that anytime you see this, I times I, the answer is -1, all the time. So whenever you work a problem, you have an I squared in it, it's going to be -1. All right? So let's continue. Let's keep going. Let's try this. Let's evaluate the following problems. The square root of -9 has no real answer, but it does have an imaginary answer. The way you would think about it, I hope, is this. You'd say 9 is perfect. 9 times -1. The square root of 9 is 3. The square root of -1 is I. The square root of -9 is 3i. The square root, let's do this one. Square root of -25, I'd write 25 is perfect times -1. Square root of 25, 5. Square root of -1, I. Answer, 5i. 12. Square root of -12, well, perfect that goes into it, 4. Not perfect, 3. 4 times 3 is 12. Of course, it's negative, so we're going to put the -1 in there. And now we just answer the question. What's the square root of 4? 2. What's the square root of -1? I. And the square root of 3? I don't know. Okay? Now, just so everybody knows this, in the back of the book, your answers will always look like this. 2 times, let's try that again. 2 times the square root of 3 times I. And I don't like this because it's hard to see that sometimes I can't tell if I is outside the radical or inside the radical. So this is what I'd rather see. This is what's going to be in the back of the book. Okay, this means the same thing as this. Okay, just to make sure you understand, this is what the book's going to say. This is the way I would like you to write it, right there. Okay, all right, page 2. Page 2 says, okay, now we have this new group of numbers. It's called the complex numbers. It's made up of real numbers, such as 5 is a real number. It's also made up of the imaginary number, I. Okay? So when you write your answers, this will be your answer in what I call standard form. Okay? So standard form is simply going to be A plus BI, where A is the real part of your answer, real part. Okay? And BI is the imaginary part. Okay? So you've got 2 parts to your answer. There's the real part and the imaginary part. An example would be 5 plus the imaginary part would be like 3i. Okay, so this is the way you write complex numbers. Real plus imaginary. Okay? Now, if you look over here, guys, I have I, and I is the imaginary number. But what is I squared? Well, we already talked about this. We said I times I is -1. So I is I. I is the imaginary number. If you square the imaginary number, you get -1. But what is I cubed? Now I cubed, you got to think of it like this. I cubed is really just I squared times I. And since I squared is -1 times the I, the answer to this is -I. Okay, I to the fourth. What's I to the fourth? Well, I to the fourth would be I squared times I squared, which is I to the fourth power. Okay, but what is I squared? I squared is -1. What's the other I squared? -1. So -1 times -1 is +1. So I to the fourth is 1. Okay? So I is just I. I squared is -1. These are the two things you always have to remember. What is I and what is I squared? Okay, from there, guys, I cubed, you can just make I cubed part, one of them you can call it I squared and then just work it out and get this. Okay? I to the fourth, you can just say I squared times I squared is I to the fourth. But I squared is -1, and I squared is -1, and -1 times -1 is 1. The rest of these are just repeats. They just repeat. So what's I to the fifth? Well, I to the fifth would be I to the fourth times I. Okay, but I to the fourth is 1. Look, it's right there. It's 1 times the I. So now you're back to I is the answer. Remember, we started with I, and now we got to I to the fifth, and we're back to I. So everything just starts repeating. So what is I? Let me just erase some of this. What is I to the sixth? Okay, this one. Okay, really quick. I to the sixth is I to the sixth, which is I to the fourth times I to the second. Okay, 4 plus 2 is 6. So we get I to the fourth, 1, times I to the second, -1, which makes -1. Notice how we keep repeating. I to the first is I to the second is -1. Then I to the third is -1. I to the fourth is 1. Right after that, we're repeating. It's back to I for I to the fifth. Then it's I to the sixth is -1. I to the seventh should be what? Well, hopefully you're saying it's going to be -I. I to the eighth. What is I to the eighth? Well, I to the eighth would be I to the fourth times I to the fourth, which ends up being 1 times 1, because that's what I to the fourth is, so the answer is 1. And there you go. We just repeated it all over. I to the fourth is 1. I to the eighth is also 1. Okay? So the question becomes, what happens when they get really big? I to the 18th. Well, you always have to go, I always do this. I always go I to the fourth. I to the fourth is 1. So I to the 18th would be a whole bunch of I to the fourths. So what I do is I take I to the fourth and I raise it to a power like 4. Now, you got to remember, I to the fourth raised to the fourth is I to the 16th. So all I would need is 2 more i's to make 18th. So there I go. Now I got this. Basically, this is I to the 16th times I to the second, which makes I to the 18th. Okay? But what is this going to be? Well, this is really, I'm going to erase something. Let me erase this. You should know that I to the fourth is 1. You're going to raise it to the first, so that's just 1. What's I to the second? -1. So now 1 times -1 is -1. Okay, so the answer is negative 1. I to the 18th is negative 1. Let's try one more. What's this? I to the 103rd power. Okay? Well, remember, I to the 4th is 1. And if you raise I to the 4th to the 25th power, you get I to the 100th. You need how much more? 3 more. 3 more. So why wouldn't you go, okay, well, I squared is easy because that's just negative 1 times I to the 1st. Okay, so when I look at this, let me get rid of this. What is I to the 4th? It's 1. Take it to the 25th power. It's still 1. Okay, this is I squared. I squared is negative 1. And I is just I. Okay, so this is 1 times negative 1, which would be negative 1 times I. The answer is negative I. Okay, hopefully you have figured this out. There's only 3 answers. One of them is I, one of them is negative 1, one of them is negative I, and one of them is positive 1. Okay? This would be just I to the 1st is I. This is I to the 2nd. This is I to the 3rd. This is I to the 4th. These are the only answers that come out. Okay? This sequence just keeps repeating. And because of that, you guys, you should know that every multiple of 4, I to the 8th is 1. I to the 12th is 1. I to the 100th, because 100 is a multiple of 4, it's still 1. Think of the sequence as you do these, okay? Continue. All right, this is going to be quick. You have addition, you have subtraction, you have multiplication. Let's just, and that's it, multiplication. Okay, when adding, you add like terms. So you're looking for real parts to be added, and then imaginary parts to be added. So to me, this says 3 plus 4 plus 2i plus negative 4i. I'm just going to do this. Drop in the parentheses. Here, this makes what? 7. This makes negative 2i. You're done. This is your answer in what form? Standard form. Okay? Okay, this is how you always write it, standard form. Complex numbers are written in standard form. Okay, this one is subtraction. Make sure you distribute it through. Negative 2 minus I. The rest of it can just be copied as is. Add the real parts. The real parts are this and this, so that's 6. The imaginary parts are going to be negative 7i. Okay? Multiplication. Foil. Just start foiling. 3 times 5 is 15. 3 times negative 4i is negative 12i. I times 5 is 5i. I times negative 4i is negative 4i squared. Okay? Now add like terms. Well, you got to remember this back part. This back part is really 4 times negative 1. Because I squared is negative 1, which is, sorry, this is negative 4 times negative 1. This is all going to be plus 4. Okay, this is out. So the real part, 15, plus 4 is 19. The imaginary part is going to be negative 7i. Okay? And that's how you FOIL it out. This is always going to happen back here. This will always be changed to negative 1, which negative 1 times negative 4 is positive 4. Okay? All right, next, it's the same thing. It's 2 plus 8i squared, so it's going to be 2 plus 8i times 2 plus 8i. Okay, and you're going to FOIL it out. Okay? If you're FOILing, it's 2 times 2. 2 times 8i, 16i. Inside is 16i. last times last is 64. I times I squared. But this is 64 times negative 1, which is going to give you negative 64. Okay? All right. Real part and real part make negative 60. Imaginary plus imaginary makes 32. I. There you go. That's it. Okay, next page. Let's see here. This is, okay, 3 plus I times 3 minus I. 3, watch what happens here. 3 times 3, 9. 3 times negative I, negative 3I. Inside is 3I. Out, last times last is negative I squared. Well, you got a 9, and you've got negative 1 times negative 1, which is positive 1. This and this are opposites, so you get 9 plus 1. The answer is 10. Okay? You should try this one. Shut the video off and just see if you get it right. Now that you've shut the video off and turned me back on, here we go. That would be 4 times 4, 16. 4 times negative 3i is negative 12i. Inside is positive 12i. Last times last is negative 9i squared. This makes plus 9. The inside terms are opposites. They're out, and 16 plus 9 is 25. Okay, what name do we give these binomials that we just worked with? Well, if you remember from last year, these were called conjugates. Conjugates. When you have 1 plus 3i times 1 minus 3i. When the second terms are opposite, when you're multiplying two binomials, we call them conjugates. When do we use them? Whenever you see division, that's when you use them. Okay? And that's where we're going next. Let's divide. Now, when dividing, there are two times you cannot divide. One is when you have 0 on the bottom. Can't do this. Okay? The other one, you cannot divide by an imaginary number. If you have an imaginary number, you got to get rid of it. So how do you get rid of it? You multiply the complex number by its conjugate, 2 plus 3i. So you do the same to the top, 2 plus 3i. Now, if you get good at this, the bottom is easy, because really all you have to do is first times first, 4. Middle, outside, inside cancel out. So all you have to really do is last times last, negative 3i squared. And I did that wrong. It should be negative 9i squared. Okay? The top you're actually going to have to FOIL, because you're going to get 4 plus 6i minus 2i minus 3i squared. Right? Okay. Continue. The bottom, you should know, this is negative 9 times negative 1. This really says plus 9, which is 13. All right, ready? This on top right here is negative 3 times negative 1. This makes positive 3. Well, you got a 4. You got the 3, which makes 7 plus 4i is the answer. Okay, now put it in standard form. This is the way they're going to do it. All complex numbers are put in standard form. What's that again? It'd be real part, 7/13, plus imaginary part, 4/13 I. That's how you do it. If you ever can reduce it, reduce it. 7/13 doesn't reduce, 4/13 doesn't reduce. Okay? That's a lot on add, subtract, multiply, divide. This is just radical times radical. Now, just really quick, when you do these problems, take these imaginary numbers and just simplify them first. So if I were to simplify this one, I'd do the square root of 3 times -1. I'd also do times square root of 6 times -1. 6 is not perfect, 3 is not perfect. But if you do this, the square root of -1 is I times the square root of 3. The square root of -1 here is I times the square root of 6. And now when you look at it, you got I times I, which will be I squared. Square root times square root. Well, you got 3 inside, 6 inside, you get 18. Okay? You know 18 breaks into 9 times 2. I'm not sure what happened there. Get rid of this. Well, 9 times 2, square root of 9 is 3. Then you have the I, and then the square root of 2. And there's the answer for this problem right here. We'll call it number 1. Okay, you should try 2, and then turn the video back on, or the recording back on. And then try 3, and turn the recording back on. Okay, here we go. Now that the recording's back on, and you've done it, hopefully this is how you did it, you probably broke this into 16 times 3 times -1. This one, 9 times 3 times -1. This one is going to be 4I square root of 3 times 3I square root of 3. Now if you just look on the outside, you got a 4I times a 3I. Well, 4I times 3I is 12I squared. Radical times radical, 3 times 3, 9. But the good thing about 9, square root of 9 is, we're looking at what number? 3. 3 times 12 is 36I squared. But 36I squared is really 36 times -1. Answer, -36. Good? I hope. Uh-oh, did I do that wrong? I think I did it wrong. Hang on, let me go back up. No, I did not. I'm sorry. That's right. That's right. Let's go down below and do this one. Okay, this one is -1 plus square root of 3, square root of -3 squared. So the way I would do it is I'd go like this, -1 plus, what is this? The square root of -3 is really just I times the square root of 3. Because this is -1 times 3. That's where that -1 inside gave me the I. Okay? Now again, you have to FOIL it out because you're squaring this. This, take it times itself. 1 negative plus I square root of 3. Okay? FOIL it out and you get this 1, this -I square root of 3. Inside is -I square root of 3. Last times last is what? I times I is I squared. Square root of 3 times square root of 3 is square root of 9. Okay, be careful with this one. 1. These two, when you add them, how many square roots of 3 do you have? -I plus -I. So -1I and -1I make -2I. This is where you got to be careful. This is really just 3. This is really just -1. And you're multiplying, so it's going to be 3. All right, the real part. 1, take away 3, negative 2. The imaginary part. There you go. And there's your answer. For number, I guess I don't have these numbered, but I think that's number 3. Okay, that is it. Then there's one more problem, and it's the next slide. Here it is. Graph the function right here. 3x squared minus 2x plus 1. Identify any zeros. I'm going to use my graphing calculator, and when I use it, here's what it looks like. The graph looks like something like this. Here's 1. And I'm thinking this is 1. But the graphing calculator kind of says this is the graph, okay? All right. Well, and identify zeros. Where do you see zeros? Well, zeros are where it hits the x-axis. Since it doesn't hit the x-axis, there are no what we call real zeros. Okay, in this section, you'll get probably no real zeros, but then it says to solve it. When will your function equal 0? Now remember, this function is this function right here. Okay? But see, the thing is, there's always got to be solutions. So if it's an x squared polynomial, we talked about this. How many solutions will there be? How many zeros will there be? How many x-intercepts? Okay? How many zeros? Well, in this case, we got none. But how many solutions? Okay, we said earlier in chapter 2 that if it's x squared, there are 2 solutions. And here's the deal. There are no real solutions, zeros, but there are 2 solutions. What kind of solutions are they? They are imaginary. How do we find them? Well, we set it equal to 0. And we solve it. Now, if we could factor, there would be real zeros, but we can't factor, so there's no real zeros. So here's where you have to use your good old friend, the quadratic formula. Negative b plus or minus square root of b squared minus 4ac. All of it over 2a. Here we go. That equals x, by the way. So your answer will be, gotta know your A, gotta know your B. A is 3, B is negative 2. C is 1. 1. Okay, so here I go. Negative B, which is 2, plus or minus, square root of, square the B, minus 4 times A, 3. C, 1. All of it over 2. Times A. You are going to get 6 on the bottom. You are going to get 2 plus or minus. Here's where you might go wrong, right inside here. This is just 4. This is negative 4 times 3, which is negative 12. And negative 12 times 1 is still negative 12. And here comes your answer inside, the square root of negative 8. So you might get it wrong with that. That negative 8 is the hardest part to get. Get that inside number. So this reduces, or simplifies, I should say, 2 plus or minus. Okay, square root of 8, or negative 8, breaks into this perfect square times 2 times negative 1. Over 6. 2 plus or minus the square root of 4, 2, the square root of negative 1, I, and the square root of 2. Okay, we're almost done, guys, almost. Okay, you have actually 2 parts. You have a real part, 2/6, which you know breaks down to 1/3, plus or minus, and now you have the imaginary part, 2/6i, which is really 1/3 I times the square root of 2. You don't need to write this little Oh, the I you need, the 1 you don't need. Okay? So you need the I. Okay, so this is your complex answer. These are actually your solutions. Now, the funny thing is there were no zeros when you looked at the graph. Okay? So when you look at the graph, this thing does not hit the x-axis, so there's no zeros. But are there solutions? Yes. How many? There should be 2. What are they? Well, they're imaginary, and they're right here. Solutions are right there. Okay? All right. I hope you filled in your notes. I hope you can get going on this maybe over the weekend. If you don't, then on Monday you have to do day 1 and day 2. I will not be teaching this lesson. You have to fill in your notes listening to this recording. All right, that's it. Have a good weekend. We'll catch you Monday. Bye.